Now we're going to be finding the resultant of a parallelogram, which you know we can only get through using the parallelogram law of vectors. Now, the parallelogram law of vectors states that two particles, and there are two particles moving simultaneously with what? Uniform velocities. So two particles U and V are moving with what? Uniform what? Velocity. So this U would also have some moving uniform velocities, which is U, and this one also be what? V. Now this U because of this place, and this V because of this place, which you know is a parallelogram, right? Okay. Now how can we calculate its resultant? Now this is resultant here. Okay? Now for it to get this resultant, we have to make this a right angle triangle. Now note something, this U now is having an additional length to it, which is this place. So let's label this place. It starts from X, this one Y, right? Good. Now, since we want to calculate the resultant, they always give a given angle. This angle. Now this angle will be equal to this angle. How do I get that? That means if there was nothing here, this full angle because this one. Now I've told you corresponding angle. Now let's slice this into two. This, since it's the same line that slashes this thing, it will be this place will be equal to this place, right? And we see here will be X, here also will be X. If here is Y, here will also be what? Y, right? Okay. Now if you draw something like this, what's it forming? More like a parallelogram, right? So it's a rough sketch. So you see, same thing happens here. This place is equal to this place. Do you understand? Good. So from here, we are looking for our resultant, which is this place, right? And corner here is theta, so here also be what? Theta. If the whole of this place is theta, here also be what? Theta. So now, let's get this place. Let's get this place. Now let's bring out this triangle. Now we have made a right angle triangle, and this right angle triangle we have two right angle triangles present inside of it. We have this one, this small one, and this bigger one. So let's bring the smaller one outside. Now if we bring the smaller one outside, it's like this. Right? This smaller one. It has theta, it has U, this U is equal to this U. We have the Y. Now, if it's going, what the difference you need to know, if it's acting upward, if you're going upward, you're not moving the distance from here to here, you're going a particular height. So, you've moved here, this one is given, then the height you move. So, we're concerned about these two things, this place and this, the height you attained, because you're attaining height now. So, since we are looking at, we're going to put our formula, our well-known formula, so, ka, swa. Now, in this place, you're given your what? Opposite. Opposite was given, which is the Y, over hypotenuse, your U. So what's this, the Y here? The Y will then become U, sorry, sin theta. Sin theta, please forgive me. U sin theta. Can you see that? Now, if we still bring this, let's say for instance it's acting downward. If it's acting downward, that means you're coming down, you are still giving this U, you're coming downward, good, right? You're not thinking about the height you attain, you didn't attain any height now. You attain from this point where you started, it's the same to this place. You attain from this place down to this place. So you are giving this place as the X, so we want to find the X, right? So we say, what are the things we're giving here? We're giving the hypotenuse, we're giving the adjacent, so it's cos. So now, cos theta will then be equal to dx over, which is your adjacent over hypotenuse over your u. So what's your dx? Your dx then equals to what? U cos theta. Can you see that now? So now we replace everything in this place. So what's the y? The y is then equals to what? U sine theta, and our dx equals to what? U cos theta. Like I firstly said, I said you have an additional length to this triangle. Now we have, let's say for instance this is 5. Now you added 2 to it, it becomes 7. So since we've added new length to this one, it will become, this total length here, from here to this place, will become v plus u cos theta. So now, I told you Pythagoras theorem. If you want to calculate the Pythagoras theorem, the same law will apply here. If you have an A, B, this is your resultant. How do you get your resultant? Resultant squared because what? A squared plus B squared. The square of this side, the square of this side, equals the square of this one. Do you get it now? Now, say we apply here. Let's draw the bigger. I think we had two triangles here. This small one which we brought out here. Now let's start with the bigger one. Let's do the bigger one outside. The bigger one will be like this, right? Then there was an additional, like this shape, but we are not concerned about this one here now. We're going to add it. This whole place become V plus U cos theta. Let me put it so you put some of you won't get confused. Understand? I'll call this place theta, right? But this place now won't be theta because we split this place, this theta into two. So let's label this place our beta. We can give it alpha. It's not the same with this angle. Okay? Because this one was split into two. So it was this one that was a hen. Good. So this is U cos. Now what's this place? U sine theta. Now we are calculating our result. So since we're getting our result, we apply the Pythagoras theorem again. R squared equals to what? U sine theta squared plus, A, let's call this one B, then plus what? B, V plus U cos theta. All squared. Please, some of you will just square it. When you see two terms added together, you put them in bracket and square it. Okay? Two terms added together, you put them in bracket and square it. There are two different things there. Same thing, these are two terms here, multiplied by each other. If it's one, so you have to put them in bracket. So we have, open this bracket, this one is simple to very easy to open. R squared is equal to U squared sine squared theta. Can you see that? Then plus, this one you have to open it, V plus U cos theta. Open another bracket, V plus U cos theta. All squared. Please note, these are the formulas we are concerned with one straight. Okay? So don't put the square here, sorry. You've opened it already 2 times. Like you're saying 2 squared is equal to 2 times 2. That's all. So now, let's open this bracket here. So our R squared is equal to U squared sine squared theta plus V times V squared, V times this, plus UV cos theta. You have used this V right now, put the next one, U times this, plus UV cos theta, plus U cos theta times plus U cos theta. That gives us U squared cos squared theta. Now you know we have 2 UV cos theta, so we add the two of them together. Like I said, 2 UV cos theta. So we have R squared is equal to U squared sine squared theta plus V squared plus 2 UV cos theta plus U squared cos squared theta. Can you see what I did there? I've added both of them together. Now, can you see that? So what's the next step now? I've taught you, note that I've taught you before. Most of my students I say cos squared theta plus sine squared theta is equal to what? 1. So if you notice something, we're having sine squared theta and we're having cos squared theta. So let's bring the two of them together. So from this place we have R squared. Let's bring out this 4 squared to this V squared. We brought out this one out. Plus U 2U U squared sine squared theta. The other side cos squared theta, right? This one plus U squared cos squared theta, right? The brother this one and the last one 2UV cos theta. Can you see that now? Now we know that sine squared theta plus cos squared theta equals to 1. So R squared is equal to V squared plus U squared, factorize it, sine squared theta plus cos squared theta. If you factorize it, you bring out U squared out. That's the common thing between the two of them. Plus 2UV cos theta. So since we go to what sine squared theta plus cos squared theta, that's 1. So R squared is equal to V squared plus U squared, bracket 1, plus 2UV cos theta. Note bracket means times. So R squared is equal to V squared plus U squared times 1, U squared, plus 2UV cos theta. So that's the formula for calculating resultant, which is up here. Now the last but not least of them is to calculate this angle here. the angle which is beta of this triangle. So to calculate the angle, we use our normal formula tan theta. Now what's tan theta? Where's my square to y? I think I wrote my square to somewhere. Yes. Opposite of adjacent. What's our opposite here? Opposite is here. U sine theta over beta. Adjacent, what's our adjacent? V plus U cos theta. Right? So since you have this, we are looking for beta, not tan beta. So we push tan to the other side. When you push tan to the other side, it becomes tan, it becomes inverse. Listen to me, note, anytime you're moving, what join tan and beta together is multiplication sign. So when it crosses to the other side, it becomes what? It becomes what? An inverse. Okay? Good. So beta is equal to what? Tan inverse of U sine theta over V plus U cos theta. In our next class, we're going to be working on division mostly because of this tan inverse. Might give you guys, it's more like saying divide both sides by tan, that's all. Okay? So beta is equal to tan inverse of U sine theta plus V cos theta. So in our next video, I will be bringing out a question that we're going to solve together. So 3 questions we'll solve together. And if you have any question that's giving you a problem, just drop on my YouTube channel, just send a message on my YouTube channel. Please, before leaving, please kindly like and subscribe to my YouTube channel. Thank you. Was I fast this time? Yes, I did 11 minutes. Oh boy!